Hey everybody, how you doing? Happy Easter. I hope you're having a great Easter holiday. Maybe having Easter brunch with your family and you had an awesome Easter egg hunt. Um, I'd still before spring break, so I haven't done Easter yet, but I'm really excited. I think my daughter, she's like 2.5. I think she's going to be excited and look forward to the Easter egg hunt, whereas so far it's just been Daddy running around finding the eggs and hiding them. Anyway, um, now we're going to learn about z-score. And if you remember those probability questions we were asking before, like the watermelon seed problems and stuff, z-score is a way for you to basically do the exact opposite, backwards problems. This is the z-score formula. I will introduce it in class on Monday. But z is equal to x, your data value, minus your mean, divided by your standard deviation. And your z-score tells you exactly how many standard deviations you are away from the mean. Alright, I have some examples. For every example in this problem, we have a mean of 70 inches and a standard deviation of 2.5. Down here, even though z-score, you don't need this graph as much because this is a way to, this equation is a way to use to find your number of standard deviations without making a graph. I think it helps to understand this problem looking at it. So the z value for 67.5, if I look down here, 67.5 is here, and here's the mean, and this is one standard deviation away from 70. So the answer is going to be 1. Oh, but because it's to the left of the mean, the number is less than it, it'll be -1. And if you follow the formula, it works out the exact same way. Z equals the data value, 67.5, minus the mean, and the mean is 70, divided by the standard deviation, 2.5. And this works out to be -2.5 divided by 2.5, which is -1. So a z-score of -1 tells you that you are one standard deviation to the left of the mean. Next one, 72.5. Well, if we look at 72.5, we are one standard deviation to the right, so the answer should be +1. And let's do the math. Z equals 72.5 minus 70 divided by the mean, divided by the standard deviation, 2.5. That gives me 2.5 divided by 2.5, which is +1. So a z-score, a z-value, a z-score of +1 means that you are one standard deviation to the right. Now, this doesn't seem very exciting because you can just look down here and tell, yeah, z-score of 1, z-score of 2, 77.5 would be a z-score of 3, 65 would be -2. Like, you can just look at the chart and do that. Z-score is handy when you need to use decimals. So what if they're not giving us 67.5? What if they're giving us, example D, more than 74 inches? So 74, if we look at 74, 74 isn't on our graph. Well, it is, but it's not one of those exact values, like 74 is right here. So it's going to be shaded here, plus here, then plus the n. So it's 0.15 plus 2.35 plus this little bit here that we're not really sure what it is. But we can find that out using z-score. So this is what we do. Z. First we got to find out the z-score. Exactly how many standard deviations are we from the mean? So the data value, 74, minus the mean, 70, divided by the standard deviation, 2.5. Get a decimal on this, and you're going to go as accurate as possible. I think this one's going to get us pretty exact. 74 minus 70 is 4, divided by 2.5 is 1.6. So I am 1.6 standard deviations from the mean. So if you think about it, here's one standard deviation, here's two standard deviations. So 1.6 standard deviations approximately there, and I want more than that. Alright, this is where it gets tricky, because we're going to bring a z-table into the formula. And how do we use a z-table? Well, over here are z-scores for the unit and then a tenth, and then over here it goes to a hundredth. So if I wanted to find a z-score of negative 2.93, I have negative 2.9 here, and then I go to 3, so negative 2.93 would be 0.0017. Okay, so we'll talk about what that means in a minute, but in the meantime, I need to find the z-score for positive 1.6, and just to be clear, this is, because this chart goes to the hundredth, it's 1.60. So over here on the other side, I've got my 1.6, so 1.6, and it's 1.60 right here. So I'm at 94.9452. So what that means is that in my z-chart here, that what it basically tells you is the percentage of where you're at. Like this is at 0 percentile, because you get a really bad score. If you get here, you're at the 50th percentile, so 0.5, and if you're at the very top, you're at positive 1. So when it gave me a z-score of 0.9452, it's saying that, boom, that right here at this 0.94, that it's all of this shaded area. That's the area of this. From here all the way to here is 0.9452. Now in this problem, I wanted the group who has a height of more than 74 inches, so I actually don't want these numbers, I want these numbers. So instead of using 0.9452, I'm going to use 1 minus 0.9452. And 0.9452, whoops, 1 minus 0.9452 is 0.0548. And that's the decimal. So if you go to, if you go to percent at that point, it'd be 5.48%. Yay, z-table. Okay, next one. Probability that a randomly selected member of this group is less than 68 inches. All right, well, if I look back at my chart, 68. Yeah, that's like, it's a little more than 67.5, but it's not an exact z-value, meaning like an integer value. So I got to figure out the decimal approximation. So 68 minus 70 divided by 2.5, that's negative 2 divided by 2.5, which would be negative 0.8. So I take it to the z-table. 0.8, oh, negative 0.8, negative 0.8 is at the 0.2119. So if I think about it, if I go back to my picture, sorry about that, I have 0.2119. And if I go to my picture, what that's telling me is at 68, which is roughly here, that this value of 0.2119 is this value from here to here, all of this filled in. And if I think about it, in this particular problem, I do want the heights less than 68 inches, so that's exactly what I want. So I don't do the 1 minus thing, I go with the exact one, which is 0.2119 if you're answering decimal, or 21.19%. Now, what's the probability that a randomly selected member of this group is between 68 and 74. So if I think about that, that is between the two numbers. So that is going from here to here. Now the first time when I did my first z-score, I got this 0.9452. When I did it the second time, hold on one sec, everybody. Excuse me. Would you stand outside and make sure nobody comes in so I can keep it nice and quiet till I'm done with this lesson? It'll be like 1 or 2 minutes. Thank you. Sorry, fourth period. Okay, back to this. So in the previous couple problems, when I had 74, 74 represented the 0.9452 from here all the way to here, and then this 0.2119 represented from here to here. So if I wanted the filled in part, I go the entire thing minus the bottom thing. So 0.9452 minus 0.2119, 0.9452 minus 0.2119, and I get an answer of 0.7333, which we change to a percent by going to 73.33%. And that's the complete range. So that is how you can do these probability problems when the numbers are, when your z-scores aren't exact, when they're decimal approximations. And that's all I have for you today. So I hope you have yourselves a great rest of your Easter, and I'll talk to you tomorrow. Bye-bye.